Sayın Doktor Bouwstra, Hollanda'da program kaydığından dolayı ben de kaydım. Evet, dünyada infeksiyöz bronşitisin durumunu anlatacak. Bir global yaklaşımla infeksiyöz bronşitisle ilgili bilgi verecek bizlere. Yes, please.
Thank you for the introduction again. Well, I'm still the same person. I can introduce myself again, but I think it's not needed. But it's again me, my person, standing between the program and the break, so I will hope to keep in time, so we have enough time for the break and the discussion over there. This time my talk is about infectious bronchitis, and I have to tell you that I did prepare it with Sjaak de Wit. I think a lot of people know Sjaak de Wit from the Netherlands, a really expert in the field of infectious bronchitis, and therefore I prepared a presentation with him. And it's called Worldwide Perspective on Infectious Bronchitis. Taking a look at the virus, the first thing that I was wondering about is the name. If you compare it to avian influenza, it's really difficult to remember all the different types of infectious bronchitis. It's a different disease, of course, but the name is not a logical one. And I asked Sjaak, what's the D for? And he said, yeah, that's our famous location in Doorn in the Netherlands, where we detected a lot of sero and genotypes of infectious bronchitis. So that's why you see a lot of D types of viruses occurring in the infectious bronchitis phylogenetic scheme. And just take a look at this picture, and it's really impressive, the number of variants that are in the world. It's a coronavirus, a single-strand RNA virus, and it has a relatively high rate of mutations, which means that there are still developing new variants, like every RNA virus is doing. And there are also recombinations occur. There are many serotypes and genotypes, and the most important ones are mentioned in this slide. And the virus is sensitive to detergents and disinfection. And it's also, well, we heard a lot about biosecurity this day, and also for IB, it's important to take care of feces, for example. And of course, biosecurity is, well, I think if you talk about animal health and preventing spread of diseases, biosecurity is the main issue. Here you see some papers which represents the number of genotypes circulating in the Middle East, and the important ones are represented here in the left column. For example, the MES type, the Q1, the D274, and some papers representing the epidemiology of avian infectious bronchitis in Iran. And there was a publication in 2012 showing a novel type in Egypt, for example. I heard from the people here that the variant 2 is the main dominant type circulating here, and that is one that gives also nephropathogenic symptoms and, of course, egg drop symptoms. If we look at IBV globally, there are some important points to mention. There seems to be an increase of nephropathogenic strains, and that's of a real concern, because if there is a nephropathogenic strain, the clinical signs on a farm can be very severe. For example, the QX type in Europe, Asia, and parts of Africa, Q1 in Latin America, Middle East, Asia, and Europe, the variant 2, which you also have here in Turkey, in the Middle East, BRI, and Australia, 3 subgroups reporting with some nephropathogenic clinical symptoms. And the big question in IBV world is, how many genotypes are there? Well, if we just take a look at our own laboratory, one of the biggest veterinary laboratories in the world, GD, we already detected 3 new genotypes over the last 3 months. So, in fact, we don't know exactly how many genotypes there are in the world. And there's also a big question about the role of wild birds. Sometimes a completely new genotype occurs in poultry. And the question is if these types occur and are introduced via wild birds. These are sort of coronaviruses, maybe mutated and adapted to poultry species. And the other way around, in non-poultry species, like the pheasant, also IBV-like viruses are detected. They are genetically not very different, give also respiratory signs and nephritis, and in chicken they give no disease, well, some cholestasis, but they do give seroconversion, so they induce the immune system by making antibodies. If we put IBV in pheasants, there is no infection. And many IBV-like viruses in all the species are found. However, it's unknown whether they are a danger for chickens. But they might be a source when a completely new genotype appears. So it's good to keep that in mind. Also for IBV, it's important that there might be a role of wild birds. And again, it's very important to take care of biosecurity and to prevent direct or indirect contact with the wild bird species. Well, a main summary of infectious bronchitis, looking at a worldwide perspective, is that an increasing number of countries have to deal with an increasing number of variants. And that makes it also difficult to do a good prevention of the disease. Some variants stay for a longer time and others come and go, so they can completely disappear. But they can reappear again if they are, well, somewhat hidden. In many countries, broad protection is needed. And this presentation, one of the questions for the avian influenza presentation was about the veterinarian factor. Do veterinarians spread diseases? This presentation is also about the human factor, because, well, you can say a lot about vaccination and what you can do, and that you have very different genotypes and different schemes for vaccination, but there is also a very important other factor, and that's the human factor. How do they applicate the vaccination? And is the application in a good way, and is there a correct scheme? And I will show you some of the practical results from our laboratory. The disease of infectious bronchitis depends on the pathotype, the strain of course, and there's a variation within serotypes, the type of chicken, the age of the chicken. Younger birds have more severe clinical signs. The climate, ammonia, dust, E. coli, other infections, and of course the combination of infections can give a severe clinical disease. The protection against IBV depends on the vaccination scheme, the application, but also the serotype and the protector type. And then diagnostic is very important. If you are able to diagnose the right strain, then you better can prevent infection, because your vaccination can be based on that knowledge. IBV, together with other infections, mainly give more problems than the infections alone. For example, a combination of IBV infection and E. coli gives far more mortality than one of those infections alone. So, if you are not able to deal with one of those infections, it's better to prevent, for example, in this case, infectious bronchitis virus infections by doing a good vaccination program. The combination of the two infections, and here you see the sum, 1 plus 1 normally is not 3, but if you have the infection of IB with E. coli, then you have severe problems. And also the combination of ILT, we heard it in the previous presentation, and IBV resulted in 80% mortality, while ILT alone only had 40% mortality, and IBV, there was no mortality at all in this experiment. So if you are able to prevent IB in this case, then you are able to prevent a lot more problems. Also with mycoplasma, you see that IB with mycoplasmas give lots of more problems than the infections alone. In this case, IB resulted in 24% of eggs with eggshell abnormality if there was a co-infection with MS, the EAA strain. And also, if there is a co-infection with the amyloidosis strain, there was much more clinical signs with amyloidosis in the chickens. And the same is in place for MG, coryza, H9N2, ORT. Avian influenza, I talked about that before, and then if you just take a closer look at the H9N2, which is also a problem in this country, then the co-infection of IBV and H9N2 gives severe problems. In this study, 20-day-old broilers were infected, and there were 3 groups. There was a negative control group, a group that was infected only with H9N2, and there was a group infected with H9N2 and IBV H120. And in the combination infection, the group with the combination infection, there were much more respiratory signs, 10% mortality, and longer excretion of the H9N2. So if you are able to prevent the IBV infection with a good vaccination program, then also the clinical signs from the avian influenza H9N2 will be less. In fact, it might be only a subclinical disease, which low pathogenic avian influenza can be. If we look in the broilers, then there is a damage of IBV infections by decreased feed intake and growth, sneezing and gasping, rales and nasal discharge. You can see flip-overs, sudden deaths by choking. The swollen head syndrome can also be caused by IBV infections, air sacculitis by secondary bacterial infections, and condemnations, nephritis, good mortality, and very wet litter. These are the main clinical signs you can see due to IBV infections in broilers. And here you see some pictures. The left upper one is a chicken with a swollen head syndrome, perihepatitis. Oh. In this picture, really sick chickens in this one. And here you see a trachea with a plug with a local tracheitis. In layers and breeders, we also see clinical symptoms. Decreased feed intake, and in cage systems, sometimes sneezing, wet eyes, and on the ground, sometimes you also see the swollen head syndrome. And the main problem, of course, is the drop in egg production and the egg quality decrease. And here you see a picture of what can be the result of an infection in layers with a severe drop in egg production. But you can also see peritonitis, nephritis, good damage of the testis, and a big problem in layers might be the false layers. The IBV strain D388 or the QX strain can give such false layers. These birds look and act like laying birds, and the pelvic bones are really wide open, but there's no egg production at all. And there seems to be irreversible damage of the oviduct, while sometimes you really see active ovaria. In this picture, you only see cystosis ovaria, and here you see active ovaria, and there is most of the time something damaged in the oviduct. And this is caused by a very early infection with a very pathogenic IBV strain, like the D388 or QX strain. And these chickens, which are infected at that moment, didn't have relevant maternally-derived antibody against the strain that is causing the infection. And this can be a main problem, and in assurance issues, it's very important to diagnose whether there's a case of a false layer due to an infection. Some pictures about the nephropathogenic strains. Here you see an example of kidneys which are damaged by the virus infection. Here you see an ureter which is stuck or blocked by an infection. A typical histopathological picture of an nephritis. And here you see the immunohistogenic coloring of an infection with the virus here in the colored parts of the tubuli. The clinical signs of infections are, however, strain dependent, and you see more problems in very young birds, but also the temperature is very important. So if there is cold environment, then the clinical signs might be severe, more severe. And indeed, if you have your feed is not from a good quality and the kidneys are already stressed by the feed, then the symptoms of an infection can be more severe. And again, it's very important to diagnose which strain you are talking about. Only in that way you are able to prevent new introductions. If you just take a look at the strain typing methods you can use to type the IBV strain which is circulating, there are some old-fashioned methods to type the strain. And that's, for example, the serotyping method and the epitope mapping. And for these types of diagnostics, you need monoclonal antibodies. And because there are so much different variants and genotypes, these kind of methods are not used anymore that much. And most of the time, the strains are typed via genotyping, molecular diagnostic tools, by RT-PCR, for example, or more fashioned sequencing. And this is the way how we now normally type the IBV strains. If we look at the chicken, well, there's one big question. You want to prevent clinical signs from an infection, and the most relevant, therefore, is that the vaccinated chicken is well protected against the challenge. And if it is so, then you speak about a protectotype. So the vaccine and the challenge strain are of the same protectotype. If you really want to check that for every different or new genotype, you need animal experiments, and of course these experiments are very, very expensive. We did some of those experiments at GD Animal Health under controlled conditions, but still I already said, in the last 3 months we had 3 more new genotypes. If you should do for every genotype such experiments, well, that's really a lot of money. Genotyping can be done in different ways, and the main reason to do is to characterize the strains based on a part of the genome. And because there is a high variability between IBV strains, there's a high demand for suitable primers to be able to detect all strains, because you want also be able to detect new strains. You have to develop new primers and probes to be able to detect them. There are in fact 2 different approaches you can use with genotyping. You can do sequencing of the S1 gene, and then you have a broad sequencing of a big part of the genome. And this is, with this type of sequencing, you can, for example, differentiate between field virus and vaccine virus. And, but there is some complication with the mixture of strains. Sometimes you don't see whatever the strain, if it's really a new strain or a combination. The other way of doing molecular diagnostics is to use a sort of multiplex RT-PCR method. And this gives you an answer for the PCRs which are in the multiplex, whether the strain is there or not. It's just a yes or no answer. And you only look for the strains you expect to be there, or the known strains, because you cannot, with sequencing you detect every strain, but with RT-PCR and multiplex PCR you just say the strain is there or not, a yes or no answer. And therefore there is no differences detectable within a genotype, but there's one advantage: it's hardly any complications with the mixture of strains which you have with complete sequencing of the S1 gene. This is a very interesting picture about the relation between the genotype and the protectotype. A combination, these studies which are in the bottom of the figure were summarized in this figure. And it gives the correlations between the genetic homology for S1 gene and the level of cross-protection. And there are striking things in it. Of course, if you have 100% homology between the S1 gene and the challenge strain, then you have a high level of cross-protection, also 100%. But as you can see from this figure, there are also strains that have, yes, there it is again. With 80% homology in the S1 gene part, but only a cross-protection of less than 20%. So there's a high level of homology between those in that S1 gene, but there is a low percentage of cross-protection. And the other way around also occurs, so only 30% homology and almost 80% of cross-protection. So it's not that you can say from the percentage of homology how good the protection will be. Of course, if it's just homologic, then you can say 100% protection, but in the other percentages it can change and it differs a lot. At our place there was also done a meta-analysis of 18 IBV vaccination challenge experiments with 137 groups, 10 clusters, several vaccines were used and there were 8 challenge viruses used. And they looked for also the protection score. If you just look at the vaccines, of course, if there is no challenge, so the negative control, you have a high protection score, but there was no virus, so that's also logical. And if you do challenge without vaccination, then you see a low protection score. It's also logical because there was no protection at all, there was no vaccination. If you vaccinate with an homologous vaccine, in this case, then you have 97% protection score. And that is for several strains, except for the strain D1466, which gives only 54% of protection score. And also interesting, for the homologous vaccine, but then applied in the field, then you only see 33% of protection score. I already told you that the human factor is very important. A lot of experiments are done under controlled conditions, so then the birds are really vaccinated, you know what time exactly, how many vaccine was used, and so on. And if we do the same study under field conditions, then you already see a decrease of protection of more than 60%. And other important fact from this study is that heterologous, a single vaccine already gives protection of more than 50%. And if you use 2 strains, then there is a protection score of 75%. So also in that way, you are able to give good protection in your flocks. There's some general rules about IBV vaccination. In young birds, in general, homologous strains provide best protection against homologous challenge. And if you want to broaden your cross protection, then you can do it by repeated vaccination, for example, at day 0 and day 14 of suitable combinations of vaccines, and by a vaccination at the day of hatch with a suitable combination of IB vaccines. And as you saw from the results from the studies I showed previously, not every variant requires a special vaccine because there's also some cross protection, although you are not vaccinated with the homologous strain. To give a broad protection by combinations of live IBV vaccine, you can use several strategies. For example, at day 0 and day 14, and then you have vaccination at the hatchery and reliability for the first vaccine. Because I also showed you that the application in the field is not always that reliable and protection might not be as good as you hope so. But if you do it later on, then you have less influence of the maternally-derived antibodies, and there's no interference between the IBV vaccines. If you do a combination at day 0, the hatchery reliability for both vaccines, it's very reliable method, and you have more influence of the maternal-derived antibodies, and there's a potential interference between the IBV vaccines. So the more vaccines you give at day 0, well, the more chance you have of interference. The previous speech was also about that. And in that case, it might be lower effective. Layers and breeders do need a long-lasting protection against the relevant field strains of that area. And the main goal to vaccinate those layers and breeders is to protect them against the damage of the egg production and the egg quality. I already told it. And then you have different advantages of a live vaccine or an inactivated vaccine. If you take a look at the live vaccines, then you can give local protection. That's most important for broilers. But live vaccination gives low antibody titers, and the protection lasts not very long, normally, in the field circumstances. If you take a look at the inactivated vaccines, then you get low local protection, but you get higher level of antibodies, and these are even more higher after live priming, and a longer period of protection. So for layers and breeders, you want a long-lasting protection, and you need, at some period, an inactivated vaccine. An important question to what is raised if you talk about layers and breeders is that induction of high antibody response, is that useful? There are not a lot of papers about that subject, and there's not a lot of practical research in the field, but there are some papers, and I will show some of the results here. In this paper, a study done by Bouwstra et al., higher serotype-specific antibodies against the challenge virus was correlated with a higher protection against egg drop. So the higher the titer, the number of antibodies in the blood, the higher the protection rate. And here you see the results presented of a study in 4 different groups, and there was analyzed what the egg production was after a challenge with IBV M41 in week 38 in layers. And here you see the group, the red line represents the group which was not vaccinated. The purple line represents the group which was vaccinated twice with an inactive vaccine at week 3 and 16. And the green group represented the group which was vaccinated with a live vaccine and afterwards was primed with an inactivated mass vaccine at week 16. And the blue one was vaccinated twice at week 3 and 15 with live vaccines. And here you see that the best protection against the egg production, drop in egg production, was in the blue and in the green group. So also the group which was twice vaccinated with an inactivated vaccine showed an egg production to a level of 60%. And of course, the group which was not vaccinated had very severe drop in egg production. This was also a study done by Bouwstra et al. And here you see the relation between the titer against IBV and the drop in egg production. And the general conclusion from this paper is that the higher the titer, the lower the drop in egg production. For example, here you see with a challenge of M41, and you have a titer of 8 to 9, it's a very high titer, then the drop in egg production was only 2%. And well, that's the same for the different experiments. Well, we also did some experiments at GD Animal Health, and also there the results were, it was under controlled conditions, but that with a 1 log higher titer, that the result was that there was a 9% lower drop in egg production after challenge. So these results together all give the idea that the higher the titer of the neutralizing antibodies, the lower the drop in egg production after an infection with IBV. The use of inactivated vaccines is highly recommended for areas with challenge. And here we are also, I think, in an area with a challenge. And it's also depending on the situation which scheme you might use. So if you can choose for a homologous vaccine, that's always good. The heterologous vaccine, that can be good. And if you insert more strains in an inactivated vaccine, that can be helpful to induce more antibodies against other strains. But vaccine efficacy is also dependent on the strains, the amount and the quality of the antigen per dose, the adjuvant and the application. And for specific strains, so new strains or really strains that mutate from others you already know, you really need to test because there is not linear correlations between the homology of the strain and the vaccine and the protection score, as I showed you before in the figure. This is a figure that represents, I think, mainly the effect of human nature. Here you see represented 3 vaccination crews. They vaccinated, well, in the vaccine they used, there was an EDS component, And the titers against this EDS component was tested. The black line represents the mean titer for the different vaccination groups. So this is vaccination group 1, this is vaccination group 2, and this is 3. The red line represents the percentage of the flock which had the titer of 1 or lower than 1. So these animals were not protected. The yellow line represents the animals that had a titer of 1 or 2. And the green line represents the animals with a titer which gives protection. As you can see, although these vaccines were the same, the animals were the same, the flocks were the same, the results of the vaccination was completely different. In fact, only vaccination crew 2 was able to have a high mean titer and a lot of animals with a titer which give protection, namely the green. A high percentage of animals had a titer of 5, 6, or 7. And the other 2 vaccination crews, for example, vaccination crew 1, almost 20% of the animals had a titer of 1 or less than 1, so they were not protected. And that's an important message. You can just have a good vaccine, you can do it in the right time, you can have a good scheme, but if you do not applicate it in the right way, then, well, you can get these results. And you can imagine that if there is a field strain introduction in such a flock, then there will be clinical signs in the chickens. The application of the live IBV vaccine can be in the hatchery or in the field, and the results of experiments indicate that the application of live IBV vaccines can be easily underestimated, which might result in a decreased efficacy. At this moment, there are many different options, but there is a little bit knowledge about controlled field trials. I think a lot of experiments which are published are under controlled conditions, and if you really want to know how to do application in practical way, you also need field data. There are some field data, and this is one of the results. Here, the vaccine application, different methods were checked for the protection, the percentage of protection after 2, 3, or 4 weeks, and here you see that the eye drop application already got 100% protection after 2 weeks of application. But for example, if you do hand spray at the hatchery, only 32% of the flock was protected for infections with M41. So there's a big difference in the vaccine application and the results and the protection percentage in the different groups. And this is also a very interesting study looking at the type of poultry and the percentage of IgM positive sera, which is an indication of vaccine application, how good the vaccine application was. And here you can see from this table that the more expensive the poultry type, the higher the percentage of IgM positives. So, in fact, human beings are able to applicate vaccination in a good way, but it depends on how important it is, because in broiler you only see that 38% was protected after vaccination, and in the broiler grandparent stock, 61% had IgM positive sera. So vaccination was really better in the more expensive animals. Results from an IBV field trial and the practical translation for how to do vaccination application in the field. You should turn off the ventilation during spraying. This gives 15.5% better protection. You should do light on during spray. It has been said before that, well, we discussed that if you have less light, of course, they are more quiet, but it helps to spread the virus and to give an effective vaccination. And a second vaccination of IBV should not within 2 weeks after the first one. And every day you wait, you get better protection of 2.5%. And cold water is also very useful. So with every degree you decrease, you get better protection of 3.2%. It's not really clear, but there were some results about the flock size and housing type, and it seems that there were cages were significantly lower response than floor housing, and bigger flocks significantly had also lower results after vaccination. Well, so in summary, some general rules about IBV vaccinations. Homologous strains provide the best protection against homologous challenge. The broadening of cross-protection can be done by repeated vaccination at day 0 and day 14 of suitable combinations of the IBV vaccines, and by a vaccination at the day of hatch with a suitable combination of IB vaccines. And in laying birds, it's very important to have a broad live priming of high quality, and the use of inactivated vaccines for boosting is an important part of the scheme. And as I said before, not every variant requires a special vaccination. And this is the most important message, and Sjaak told me, you have to say this: never ever underestimate the difficulties of applying vaccines by mass application methods, especially in the field. Because as you saw in some of the tables, although you know that the vaccine is the same, the flocks are the same, the conditions are the same, the human factor can be a big problem, and they might, well, if you do it in a right way, then the application method can give high titers, and high titers give better protection. And the known advantages of a better application are that you have higher level of protection, there is an earlier protection, so the antibodies will rise earlier, there are less rolling reactions, including secondary bacterial complications, and I also showed you some results about if you have combinations of infections. There's a lower risk for reversion to virulence, and there's less interference with other vaccinations. And last but not least, better disease prevention, higher performance, and better return of investment. And that's where we all do it for, I think so. Thank you for your attention.
Thank you very much for your nice presentation. Evet, çok teşekkür ediyoruz. Zamanında bitirdiler. Have you had fun? Okay. Şimdi Ruth'a sorularımızı soracağız. Mikrofonu aldıktan sonra kendimizi tanıtarak sorularımızı sorabiliriz. Evet. Soru sormak isteyen kimse yok mu? Evet, buyurun. Ön tarafa alalım mikrofonu. Ayağa kalkarak, evet.
Ben Ramazan Gürbüz'üm, saha veterinerim, aynı zamanda üreticiyim. Doktor Ruth'un konuşmalarına kesinlikle katılıyorum. Ama Türkiye'de biz IB'yi halletmiş durumda değiliz. Newcastle gibi. O da bizim en büyük problemimiz. Biz bu sene bir araştırmaya girdik. Ben daha çok katkıda bulunmak için mikrofonu aldım.
Soru varsa soralım. O direkt temenni kısmında şey yapalım isterseniz yani. Çünkü soru bekliyor yani katkı şeklinde. Hemen bitireceğim.
Peki. Uygulamalarla ilgili kısmı yaptığımız termal kamerayla yaptığımız aşılamalarda, sprey aşılamalarda maksimum uygulamanın en az %20 hata olduğunu gördük. Dolayısıyla tüm dünyada yapılan hata bizim ülkemizde de yapılıyor. Burada çoğunlukla teknik arkadaşlar olduğu için bunu paylaşmak istedim. Türkiye'deki infeksiyöz bronşit ve Newcastle'ı bitiremeyişimizin en önemli faktörlerinden birisidir. Evet, ülkemizde velejyonik tip 7 var Newcastle'da ama uyguladığımız aşılar sonuç vermiyor. Bunun en önemli sebebi uygulama şeklinin eksikliği ve yanlışlığı ile ilgili. Ben soru sormayacağım, bunu paylaşmak istedim. Teşekkür ediyorum.
Evet, teşekkür ediyoruz. Bu aşı uygulamalarla ilgili gruplara göre bile farklılık çıktığı ortada. Buyurun, başka sorusu olan var mı? Buyurun, arkadan alalım.
Merhaba, ben Bakbiliş'ten veteriner hekim Ahmet Kan Petek. Varyant suçların birbirine karşı çapraz korumada koruması var mı? Varyant suçların çapraz koruması mevcut mu? Teşekkürler.
Sorry, I missed half of the question.
Yavaş yavaş söylerseniz tercüme ediliyor çünkü net olarak söyleyelim. Varyant suçların, evet söyleyin.
Mesela 491 ve 793B suçu, bunun birbirine karşı çapraz bir koruması mevcut mu? QX'e karşı.
Something wrong with the headset, sorry. But I think if I understood it correctly, then your question is maybe for the local situation, which vaccines might give cross protection for the variant 2, which is circulating here. Is that correct or not? I discussed it with Jacques de Wit, maybe. The question? Oh yeah, I didn't answer the question. I didn't understand the question because it's not working. Sorry.
Tekrar lütfen soru.
Yeah, well, I hear you, but with it's.
Soruyu
I think
tekrar
it's
edin.
sort of broken.
Sorry.
Yeah, now it's okay. Yeah.
Örnek vermem gerekirse 793B'nin QX'e karşı bir koruması mevcut mu? Olur mu? Böyle bir şey olur mu yani?
Well, that's such of a detail, I cannot answer that. But what I do know is that the variant which is circulating here, the variant 2, often gives the 793B together with the mass vaccination gives cross protection against the variant which is circulating here in Turkey. But for the QX, I don't know. I have to discuss that with Jacques. Ask him, maybe come back to that later.
Okay. Evet. Sanırım cevabı aldılar. Buyurun arkadan alın. Sol taraftan, sol arkadan.
İsmim Taylan Eğilmez, Zoolojisi Hayvan Sağlığı'ndan. Öncelikle teşekkür ediyorum güzel sunum için. Ben sekansla ilgili bir soru sormak istiyorum kendisine. Genotiplendirmede bildiğiniz gibi, sizin anlattığınız gibi suçları tayin edebiliyoruz. Ama bunun aşı suçu mu, saha suçu mu olduğunu sekans yoluyla anlamaya çalışıyoruz. Peki bu sekansta çıkan sonucun %100 saha suçudur ya da %100 aşı suçudur diyebiliyor muyuz? Ya da siz ciddi olarak bunu size yolladığımız bir örnekte bu kesinlikle %100 homolog olarak saha suçudur ya da %100 homolog olarak aşı suçudur diyebiliyor musunuz? Bu bizim merak ettiğimiz bir soru.
If you can do it 100% sure, that's not what I know. But if you want to differentiate between field strains and vaccine strains, then you really need sequencing and not the method of multiplex PCR, because then you only get the answer searching for field virus, whether they are present or not. And if you do sequencing, then you can get answers whether there are field strains in the sample or also vaccine strains. And you can, for the part you did sequence, analyze whether it's 100% homology or not between those two strains. But you only select a part of the S1 gene to sequence, and well, depending if you do whole genome sequencing, then you can really see whether there are 100% homology. But if you do just a part sequencing, then you cannot answer that question. But only for the part you sequenced. But if you want to know, you need the sequence method to differentiate between vaccine strains and field strains. But not the specific RT-PCR methods. well, there might be some circulation of vaccine strains also, and it's also important to analyze whether they are there or not in the sample.
Evet, buyurun. Şu tarafa. Evet, ayağa kalkarak kendinizi tanıtın, sorunuzu sorun.
Teşekkürler sunumu için. Ben veteriner hekim Elif Macide Aral, kanatlı Ar-Ge'de çalışıyorum. Benim sorum, kendi laboratuvarlarında acaba hangi gen bölgesini ve ne kadarlık bir bölgeyi taradıklarında varyant ya da aşı suşu dediklerini, bu ayrımı nasıl yaptıklarını öğrenmek istiyorum. Teşekkürler.
It's just a part of the S1 gene, but how many nucleotides, I'm not sure. But we do use such a part that you can make differentiate between vaccine and field strains. And I can give you the information how we do this, the strain typing, because we in our laboratory only use sequencing methods nowadays for differentiating or typing the different IBV strains that are circulating in the field. Also from samples that are sent in from abroad, we can do sequencing, and I can just check for you what number of, what the length is of the S gene we do sequence.
Ama tüm genom sekanslama değil dolayısıyla, değil mi? Onu anlıyorum.
Yes. As far as I know, we do just a part, and I can imagine that if you are not, if that does not give the complete answer, then you can decide to do whole genome sequencing, but normally we do just a part of the S1 gene, and that part we do sequencing, and then you take the part that gives the variance in the different strains the most, so you can detect the difference between the strains and also detect whether vaccine strains are circulating or not.
Okay, thank you.
Evet, başka sorusu olan? Sanıyorum yok. Ruth'a çok teşekkür ediyoruz. Thank you very much. Nice presentation. Evet, alkışlıyoruz kendisine.